Whether you operate one forklift or thousands, one location or hundreds, the new My Toyota customer portal can help you optimize your operation and material handling equipment. This one-stop, free-to-use platform is designed to help you take control of your information and make smarter decisions, all at the touch of a button. Register and access your data today at my.toyotaforklift.com. That's my.toyotaforklift.com.
The New Warehouse Podcast, hosted by Kevin Lawton, is your source for insights and ideas from the distribution, transportation, and logistics industry. A new episode every Monday morning brings you the latest from industry experts and thought leaders. And now, here's Kevin.
Hey, it's Kevin Lawton with the New Warehouse Podcast, coming to you with a new episode. On this week's episode, I am joined by Zac Bogart. He is the president at Productive Robotics. You may remember Zac and Productive Robotics. We talked to them way back during our ProMat series, and one of the big highlights there was just the ease of using their robots, and the ease in the sense of being able to program them and teach them the actual tasks that they want to do. You guys may remember that he taught me like in a minute at ProMat how to teach it how to do something. So it's pretty remarkable. So we're going to check back in with Zac and talk to him about, what is Productive Robotics and what they're up to and what makes it so easy, and also some recent updates to the company and their software as well. So Zac, welcome to the show. How are you?
Great. Thank you for having me, Kevin.
Definitely happy to reconnect with you and have you back on. So why don't you give the audience a little, I guess, kind of overview of what Productive Robotics is and what it is that you guys provide?
Well, we are a manufacturer of collaborative robots, the only U.S. manufacturer of 7 jointed collaborative robots. Mm-hmm. And that's our OB7 series. We actually have 4 robots in the series that range in size and weight, all the way from a 4-kilogram payload robot with a reach of 1.25 meters, all the way up to a 12-kilogram model. Okay. So what we think is special about our robots, and fortunately our customers do too, is that they're just super easy to use. We don't have any programming, while a lot of robots have become much easier to program, we've really done away with the programming entirely. We have no programming language in the robots. Mm-hmm. So what we do is we say we teach our robots. They're not as smart as young children, to be honest, but they don't require programming to actually get them to do their job. You show them what to do, and they then can emulate and make decisions based on what they've seen you do, right. And to build up what most people call a program. Mm-hmm. We call it a job.
Interesting. Yeah, I remember you showing me how to do it, and it literally is you are just showing the robot how to do it. You move it to the task that you want it to do, and then it remembers how to do it and learns it basically, and then can just do it repetitively, and it's pretty remarkable. So why don't you tell us a little bit? You mentioned about the 7 axes or 7 joints. Why is that such a differentiator?
Well, it's not obvious at first why it's such a big differentiator, and we do have to explain it. So it's a very good question. The 7th joint is a range of motion that's very much like a human arm has, and most robots don't have that range of motion. They have 6 axes, and 6 axes are chosen often because from an engineering or a mathematical perspective, they appear to be able to reach any area within the working envelope. Mm-hmm. But as a consequence, they're very limited in how they can reach that working envelope. With the 7th axis that we've added, and if you look at how your own arm moves, you'll find that there's essentially 7. Your arm actually has more, but it's essentially 7 motions. And that allows our robots to reach in and around things. And that allows them to, because you don't generally put the robot in a place where it can't directly reach what it needs. But what it does is it allows you a great deal more flexibility in where you put the robot in a working space, which means you can put it in the space in and around where people work and still leave room for the people to work with the robot. So you can put it, for example, if it's operating a machine, which is very common, you don't have to put it directly in front of the machine. You can put it to the side of the machine. And still allow room for a person to get in there and work on the machine, but also let the robot do its job because it can reach around the barriers and the work doesn't have to be put directly in front of it. That's the largest benefit. It's like just a lot more maneuverability within a confined space.
Interesting. So it really kind of allows you to have the flexibility, like you said, and then also allows it to be even more collaborative in a sense because you give it more, it has more range of motion, meaning that you can have more space where you can work together with it, with different machinery, like you mentioned. So now talk to us a little bit about kind of that ease of use and also the ease of deployment of it overall. How did that kind of, I guess, come about, and how did that all come into play as you guys were developing this product?
Well, the ease of use, I'll split those into two questions, actually. The ease of use was really there from the beginning. Our entire concept about the robot from day one was that there wouldn't be a programming language and there wouldn't be programming. The first robotics work that we ever did was actually in the middle 1980s, designing and developing robots for special effects movies, and the robots would move a camera around. Okay. And we had to design these so that camera operators and movie directors and choreographers could make sense of them and use them. And so that there was no programming even at that point. Mm-hmm. Of course, they were a lot simpler, and they didn't do anywhere near as much as we can do now. But the idea is that we really want to make the robot accessible to more people than just the engineers in a factory. We want anybody to be able to use it. And that's why we took the approach that we took. We're a bunch of engineers ourselves, and so it led to some very interesting conversations because all roads lead to a program when you're a programmer. And so it was made for some lively debates within our team. And people would say, well, we need to make it easy to program. And that's one of the mantras that are out there about collaborative robots, is they're easy to program. And one of our pushbacks in our fight was, yes, if they're easy to program, then programmers will find them easy. Well, we don't want to make them easy for programmers. We want to make them easy for non-programmers.
Right.
And so that's what drove us in the area. So moving from there to your question about deployment,
right.
Deployment is still and will be for some time the major stumbling block for collaborative robots. The robot can be very, very simple to teach, as ours is, and as you've seen. But if you can't get it into operation within the customer's context, their factory or their machine or their assembly, it doesn't really matter how easy it is or how simple it is.
Right.
So for deployment, we have made them. We've equipped our robot with a stand that rolls, so you can actually just roll it into position, and then lower some feet to lock it in place. Okay. We've included a table that's built right into the stand that is a work staging table, so that you don't have to create a whole infrastructure in and around the robot to hold the work that you're doing, whether it's, for example, assembling something, or if it's staging parts to go into a machine, which is very common. So the stand and the table and the robot are all integrated into one. There are options. The robot is available obviously without a stand as well, but most people use it. And so So that's that was sort of step one. We include a gripper that is a very generic gripper that's under the control of the computer that has a wide range of motion, so that it's adaptable for many different kinds of things you'd like to pick up. Historically, industrial robots have used a gripper where an engineer will design specially shaped fingers that are designed specifically for the part that is to be handled and manipulated. And the gripper that we've designed and include with the robot is generic. It'll close on a wide range of parts, but it's also customizable in shape. So, and we find that most people and in most applications, they don't make any changes to the gripper at all. Mm-hmm. So that covers a wide range of things you might choose to manipulate, and then the robot has to actually work with another machine or another piece of equipment. Mm-hmm. So in order to facilitate that, we've included a special interface that's separate from the robot, and the robot just plugs into it with a simple network, and it's a generic kind of interface that can hook into just about any kind of machine that you have. So those pieces are all there to facilitate a quick and easy, what people usually call integration, right. Or we think deployment's a better term. And then we've also got a number of other accessories which is also growing, that we've created for special purposes and special interfaces and applications.
Right. So it sounds like, I mean, obviously you guys thought a lot about this in making it super simple for the end user. And I think that's really important, especially in, like you said, such a world, I guess, where, everybody is kind of programmers. You thought about the actual end user who's not going to be a programmer. So I think that's great. And I think, the idea of you guys actually looking at it and how it can work in different industries as well is, that's super timely for right now as well, because we have so many industries that are now crossing over to deal with these COVID-19 situations and doing different things as well. And, for me, what I'm really taking away from what you're just talking about is that, this collaborative robot sounds like it can easily be taken from one task and then put towards another task as well. So it's not like you're taking this one robot and it's just dedicated to this task and it's just going to do that for the rest of its life, right? Without some difficult intervention. But it sounds like, if I'm hearing you correctly, that you're able to kind of make this robot do different things as you need it to do different things. You just have to teach it, like you said. Is that correct?
Yes, that's exactly correct. And then you would then roll the robot over to the next workstation or place you want it to work when you want to change its application.
Awesome.
Once you've moved it to the new location, if it's already done that job before, you don't have to teach it again. It will remember and repeat that job.
Very cool. So I can see that definitely in a distribution format where, we do, I'm thinking about, I used to work for Keurig Green Mountain when we did a lot of kitting where we would do variety packs with K-Cups and things of that nature. And I would think that would be an awesome application for that. So you talked about, the ease of connectivity to other machines that it would be working with and all these things. And that's something that you guys developed even more with recently unveiled software update. So tell us a little bit about that software update and how the connectivity increased, and then also talk to us about, all the different aspects of that in terms of the online status monitoring and how you're able to kind of see what's going on with these robots so they can work when you're not necessarily around and you're able to kind of keep an eye on them, I guess.
Absolutely. Well, actually, there's two questions again in there, so let me break them apart a little bit. That's good. As far as the interconnectivity goes, originally when we released the robot, it would interface with its own interfaces only, and not talk to machines that were communicating over a network. Mm-hmm. So that now has been added, and that was in a fairly recent release.
Okay.
And so now you can plug in and talk to just about any device that speaks over a network. And sometimes that means that you're collecting information from that device. For example, it's a machine that says I finished the cycle, or it's a conveyor belt that says, hey, a part has just arrived for you.
Mm-hmm.
Sometimes it's giving actual commands out to something else, to another machine, to start a cycle or to do a particular operation. And so that's that interconnectivity, and it speaks multiple languages. It doesn't speak all the languages.
Mm-hmm.
It speaks all the common languages that one might use. Well, the email and text message alerts have been common in the robot, or have been existing in the robot actually now for a couple of years.
Okay.
And that's you can have OB7 send you an email or a text message at any point in the cycle. So, for example, if we're using your example, if it was packing boxes of coffee pods, if it ran out of a particular type, it would send somebody a message to say that bin needed to be replenished.
I like that.
So that communication, it's very useful and powerful. What we've also recently introduced is what we call productive analytics. And productive analytics is a cloud-based system, I guess is the right word, service, where your robots will send all their production data as they work to this cloud system, and then as the manager, you can log in to the system, to your own private area within the system. It's very secure. And then you can look at all your robots. You can look at what they're doing now. You can look at what jobs they've been doing, how many, for example, boxes of coffee pods they packed in the last hour or day or week. You can look to see if any of them are stalled for any particular reason, like, for example, they ran out of material, or they're idle because they hadn't been started on a job. Some part of the production isn't running.
Okay.
And then it'll also report errors if there are any errors. They're there to be seen. So you can really look at the complete history all the way up to the current moment, literally within a minute, of every robot that you have within your plant or plants, because it'll work across multiple plants as well. All that all resides in the cloud. It's all completely encrypted and secured, so all of the data that goes there goes up as is encrypted and secured for your use. It'll also automatically generate full reports of production reports for you, which then are emailed to you on a basis that you select, whether it's daily or weekly and so on.
We'll be back after a quick break.
You hear a lot about supply chains these days, because if the past couple years have taught us anything, it's that an efficient, well-managed supply chain is absolutely critical to keeping businesses successful and consumers happy. I'm Will Haywood, and I host a podcast called All Business, No Boundaries, where we talk about supply chains, how they work, what happens when they don't, and the innovations that are redefining what's possible in the world of logistics. Join me for insightful interviews with thought leaders and industry experts. We discuss how optimizing supply chains can break down the barriers that are holding businesses back. That's All Business, No Boundaries by DHL Supply Chain. Listen and subscribe wherever you get your podcasts.
Interesting. So I mean, is it really the reality that you can kind of set up one of these robots and have it do the task and kind of walk away and not really have to closely monitor it, and even have it kind of operate maybe on like a shift with no individuals there, or light supervision?
It is absolutely, and it's done all the time. Our customers do that all the time. So the limiting factor that limits how long it can work without any attention is simply the supply of the materials that it's working with. So, as an example, which we'll use your take-up example again.
Sure.
If you've got to be putting together packs of 3 of each of these different flavors of K-cups.
Mm-hmm.
It'll run as long as you have cups to supply it and boxes to put them in. And as soon as one of those stops or runs out, you'll need a person then to replenish the supply, and then the robot would then continue packing. But you could set the robot again, for example, to signal you or send you a message when it ran out of something. So if you want it to run all night long, or you want it to run from 6 o'clock at night till 8 o'clock the next morning, it's on you to make sure that it's got plenty of materials to work with during that period.
So it always comes down to human error, right?
Well, it does. I mean, when it comes to doing these sorts of jobs over and over again, robots tend not to make errors. They do the same thing over and over again, and you just better hope that you set it up to do the right thing, because if you set it up to do the wrong thing, which is of course possible, it'll do the wrong thing over and over as well. So,
definitely. So I mean, it's like, I guess it's like the the old saying is a student is only as smart as the teacher, right? You're the one teaching the robot, so you got to teach it to do the right thing.
You do indeed.
So now you guys also had some news around a new announcement around something called OB Vision as well. You want to speak to that a little bit?
Sure. So OB Vision was actually first shown almost a year ago, but it was not quite ready for market. It's been being worked on since then. And OB Vision is a machine vision accessory or system that installs on the robot. It will install on any new robot or any of the existing robots that are operating in the world. Mm-hmm. And OB Vision is used to locate and find things that the robot needs to pick up. So OB Vision would be taught about the object that it needs to pick up, and that teaching is part of sort of our claim to fame, the magic of OB Vision, in that it's there's no programming in the teaching. You just show it the part, and it analyzes it and learns it. Okay. So, as an example, if you had your coffee pods coming down a conveyor belt, mm-hmm. OB Vision would know to look for those coffee pods, and as they came down the conveyor belt, it would pluck them off the conveyor belt.
Interesting.
And this form of machine vision is, candor, is not new in the world. It's been happening for many, many years, but it always requires very complex motion and image processing programming. And our difference is that this system requires no programming. You just simply put the part down under the robot, push one button, the robot analyzes and scans and builds a representation of the part so it knows what it's looking for. And from there on out, anytime you tell the robot to look for and pick up that part, it will look for the part. If it's not present and it can't see it because it isn't there, it will just wait patiently until it arrives, and then it'll pick it up and then put it where you needed it to go. So while it's incredibly simple to program, it's also in candor not as sophisticated as some of the more advanced machine vision systems. Mm-hmm. It does this one job, which is really what the robot needs, and that's it. And it does it extremely well and extremely simply with no programming. And so from that perspective, it's not a replacement for some of the higher end vision systems, for example, that might look at a production of bottles of Coca-Cola coming down a machine at 500 bottles a minute and identify one that has like a crooked cap or something. Right. That's not really what this is for. This is for packaging and machine tending quickly, simply with no programming.
Got it. So, and I think I remember seeing this at ProMan. You guys had this set up, the one that you showed me. Actually, it learned, I forget what the object was, but it was an object, and it learned the object. And
you actually taught it.
Yeah,
you taught it.
Yeah, so that was a lot of fun. And so now, would it be able to? So, say I had two of these robots set up on the conveyor, right? And I had say we'll go back to the coffee pot example, and I had like a small coffee pot and a big coffee pot, could one of them know just to pick up the small ones and one of them know just to pick up the big ones?
Absolutely, very easily. But you could also teach one of them to identify the small versus the large, and put the small ones in one box and the large ones in a different box.
Oh, wow. Interesting. I like that a lot. So very flexible, definitely still, even though, you're saying it's not as advanced. I think you're underselling it a little bit. I think it sounds great still. And definitely, still that flexibility and ease of use. Like you said, it doesn't require any programming, which I think is huge. And the fact that, and I will reiterate again, it is super, super easy to teach. At ProMat, I would think I was like shocked, and you showed me the steps and I did steps, and then you're like, okay, that's it. And I was like, what even happened? I don't even remember what happened. It's so quick. So really, really good stuff. So how was the response to everything at Modex? I know Modex, we were there and we didn't get a chance to connect on site, but obviously one of the big things coming out of Modex was attendance was a little lower. But how was the response overall, and how were people feeling about the collaborative robots?
Well, the response was good. As you pointed out, the attendance was off due to the pandemic,
right?
And so we think that we probably experienced about a half to 2/3, somewhere in there, of our normal traffic. But what happens, or what we've experienced over the years in trade shows, is that when the attendance is off, it's the serious people who come still to the show.
Right.
And the people for whom it was sort of optional are the ones that tend to drop out. So the attendance or the interest in the people who came was very, very good. And I think we're selling robots already as a consequence, even in this period. And people, but it was very good for us because the majority of our robots tend to go into manufacturing operations, and the first runner-up, of course, is packaging. And it was very good because it gave us a very good perspective on extending our robots beyond just simple packaging and into bigger applications. For example, we had started down this road as well, but we sort of refined it at Modex, is that our larger robots can do palletizing off conveyor belts, or not conveyor belts, but conveyor belts is the standard, onto pallets. And it also has motivated us to release a new robot that we call the stretch model. And the stretch model is fundamentally the same as our small basic OB7 robot, but it's got a longer reach. It's got a 1.25 meter reach with a slightly lower payload. So it's ideally positioned for packaging of things like K-cups or smaller products, but in a larger area where it needs larger reach, but the things it's packaging aren't quite so heavy. So it'll handle up to 8.8 pounds. And so in that context, it's the lightest payload of our robots, but it's got this extra long reach, which makes it much more flexible in packaging applications.
Interesting. Yeah, I think that, like you said, some of the applications for the collaborative robots have been a lot in the manufacturing side, but I think now people are seeing how they can utilize them in different areas within the distribution space overall. So I like that you guys are noticing that as well, and kind of listening to what's going on out there and making some adjustments to accommodate that sector as well. So good job on your part. And also, you mentioned obviously the big talk is about the pandemic, like you mentioned, in COVID-19. So I'm curious, are you seeing an increase in demand for collaborative robots now that this is going on, especially as, employees are, I guess, taking leave and other reasons as well? Are you seeing companies have more interest in the possibility of putting in collaborative robots to kind of help their operation continue to go a little bit?
We are, and I'll qualify it a little bit. I've been seeing all kinds of marketing coming out about about products and why our product, one person's product or another person's product, is ideal in this time of the pandemic, and it was brought to us that we should be promoting our robots as replacements for labor during the pandemic and so forth. And we've kind of rejected the notion of trying to use this pandemic as a lever to increase our marketing. It's a terrible situation that's going on, and we don't want to personally try to take advantage of it. With that said, we have had a slowdown in orders at the outset of this.
Right.
And every one of the customers who slowed down has said to us, we're not stopping, the orders are coming, we're just delaying everything for a couple of months. And in fact, we believe that we'll be coming back for more and more robots after this is over, both because they can't get sick and they are anticipating a lower workforce.
Right.
But also because they're anticipating a flurry of business when this is over, because there's going to be pent-up demand for certain things. So from that perspective, yes, it's giving us indications that people will be buying more robots. But I don't think it's directly because they're saying, well, a robot won't get sick. I don't think that's exactly what's happening. At least I hope not.
Right. Yeah, I think that's an interesting perspective, especially as I think businesses kind of look at, obviously, I mean, how could you be prepared for something like this, right? It's kind of unprecedented. So as people kind of look for their future, like contingency plans and things of that nature, I think, they're definitely probably going to look towards collaborative robots as well. So really interesting perspective there. And Zac, I want to thank you so much for joining us and talking to us about Productive Robotics. How can people find out more information about Productive Robotics?
Well, you can start with our website, and there's lots of great information on our website and videos and application information to look at. You can also give us a call. You can call us and let us know what you want to do. For us, we like to work really closely with our customers and their applications. If they're really big applications, we'll often bring in a third-party integrator to help with it. But for a lot of applications, we try to enable our customers to do as much as they can, and we help them out along the way. So give us a call with whatever you want to do, and we'll work with you to make sure it happens.
Okay, great. And we'll post all that information on thenewwarehouse.com as well. So, Zac, thank you so much for coming on the show, and hope you have a good one.
Great. Thanks a lot for having me. Appreciate it.
You've been listening to the New Warehouse Podcast with Kevin Lawton. Subscribe and check us out online at thenewwarehouse.com.
Thank you for listening to this episode. If you want more content from the New Warehouse, check out our new video series called All Hands on LinkedIn. Just search for the New Warehouse on LinkedIn and follow along.